Okay, so this is the continuation of section 8.1 on graphing sine and cosine graphs. So let's do another example here. Now, we know that from the standard form that this 4 is my A, which adjusts the amplitude, and my value of B is this coefficient of x right here. It's that 1/3. That's going to adjust my period. So my amplitude now is 4. You know, the normal is 1. The new period we find by using the formula 2 pi over b, because the original one was 2 pi, and we're going to divide it by this number b. So it's 2 pi divided by 1/3. Now don't write 2 pi over 3. That would be divided by 3. We're dividing it by 1/3. And remember, when you divide by a fraction, it's the same as multiplying by its reciprocal. So if you multiply 2 by 3 over 1, you get 6. And pi's along for the ride. So I have a new period of 6 pi. That means that my sine graph has been stretched both vertically and horizontally here. So here's what it's going to look like. We've got the normal sine graph here, kind of, you know, if you want to think of one period as starting at 0, going up, back to 0, down, back to 0. This max up here would normally be 1. That would normally be -1, but because of our amplitude change, that's going to be 4 and -4. My starting point, because I did not have a phase shift of any kind, I didn't have a left or right shift, so it's still going to start right there at 0, 0. My ending point for one period is 6 pi. And how do I know that? Because the period is 6 pi. I'm only graphing one period. Okay. Obviously, we know that, you know, keeps going that way and that keeps going that way. I'm just graphing one period for you. So from here to here is 6 pi. I want to label all these in-between points. So let's talk about how I got those in-between points. Well, I knew that the sine function typically starts at 0 unless it's shifted up, down, or left, right. The ending point is my period here. Since that starts at 0, my end point is just going to be that 6 pi. The next point I got was this halfway point right here. Halfway from 0 to 6 pi is 3 pi. Sorry, my dog decided she needed to be awake now and start stretching and scratching. So if you hear jingling, that's just the little beagle. All right, so halfway from 0 to 6 pi is 3 pi. So I got that one next. Now, how do I get these other two in here? Well, halfway between 0 and 3 is 1.5. Right? Halfway from 0 to 3 is 1.5. So that's 3 halves. And then, of course, the pi there. So that's the 1.5. Now, at this point, it might be easier to just look for a pattern. So that's what I did. I had the 0. I had the 3 halves pi. I had 3 pi, which I wrote as 6 pi over 2. The 6, which I wrote as 12 pi over 2. Now, the reason I did that was to get a common denominator with this 3 halves. So where did the 3 halves come from again? It came from halfway between 0 and 3, which is 1.5. So now with a common denominator, we got 3 pi over 2, 6 pi over 2, which reduces to be 3 pi, 12 pi over 2, which we know is the same thing as 6 pi. Now it's a little easier to see the pattern. Look, 0, 3, 6, 9, 12. So that's 9 pi over 2 right there. This is going to happen every time. Let me guess, you're still itchy. Yep, there it is. I hit record and suddenly both my dogs get super itchy, or their buttholes, they suddenly realize their buttholes are very dirty and need to be loudly cleaned near my computer. So if you guys have animals, you can probably relate. So here's how we're going to do that. And the reason these are equally spaced is because of this being, you know, a sine or a cosine graph, that these max, min, and zeros are all equally spaced like that. All right, so there's one period. I know I just said graph, but it is implied that I just want one period unless I say otherwise. All right, so let's look at another example here. So this is going to be example 6. We're going to graph y equals -2 sine x. This negative right here is going to be a vertical flip, or a vertical reflection. Okay, so it's going to reflect it across the x-axis. We know that this 2 is going to change my amplitude. Okay? So my amplitude is the absolute value of negative 2. Remember, the amplitude is always positive. The negative is going to flip it vertically. Okay? So what I did was I looked at this in terms of what it would look like not flipped. So I first did 2 sine x, and that's the red dotted line. 2 sine x is the same as sine x, it's just going up to 2 and then down to negative 2. So it has the same, the same zeros and the same max and mins here as far as the x-axis goes. So we still have that pi over 2, pi, 3 pi over 2, 2 pi business. The only difference is that 2 stretches it up here to 2 and stretches it down there to negative 2. Now all this negative does is take this little red dotted line and just twists it. It flips it. So this flips across the x-axis. This down here flips across the x-axis. And we end up with this solid line graph here, which is my negative 2 sine x graph. This one's a little easier because we didn't have any period change and we didn't have any kind of left or right or up down shift. We just had to adjust the amplitude and then that flip. But I wanted to point out to you that if there's a negative here, your amplitude is still going to be positive. Now your amplitude is always that absolute value of that number A. Example 7. We're going to have a phase shift with this one. Going back to our standard form, we know that this, if there's a plus or minus right here, that's going to be a left or right shift. Because it's a minus, it is to the right pi over 2 units. I know that's backwards from what you might think. So I have an amplitude of 1. How did I get 1? Well, because that value of A right there that's not written, that's an understood 1 to be right there. My period is still 2 pi. How did I know that? Well, I don't have anything right here. Well, I have 1. I shouldn't say I don't have anything. I have a 1 right there. So my period's 2 pi over B, B being 1. Right? So right here, I have that A is equal to 1. Right there, I have B is equal to 1. And then I've got that phase shift that's to the right pi over 2 units. Now for phase shifts, I tend to say them based on which direction they go. WebAssign is going to do it a little differently. If it's to the right, they want you to put positive. Pi over 2 is the phase shift. If it's to the left, they want you to put negative. So I'll remind you of that as we go along, but just know that going in. Okay, so here's what we get. My starting point for the sine function is normally, for one period, is right here at 0, 0. This is going to shift it to the right pi over 2 units. So we know it's going to look like this, the sine curve shape, just shifted over to the right pi over 2 units. Now let's talk about how I got these numbers. Pi over 2 here to the right of this 0, 0 because of that shift. Then next up I got my end of one period. From pi over 2 to 5 pi over 2 is a distance of 2 pi. So from here to here, that's one period, that is a distance of 2 pi. If I add pi over 2 to 2 pi, I'm going to get 5 pi over 2. Now let me just show you some of those computations here. So the phase shift had me a start value of pi over 2. So right here is one period from pi over 2 to 2 pi, or to the from pi over 2, my starting point, to the end, we know is pi over 2. Adding those together, I get 5 pi over 2. That is because this 2 needs to be thought of as 4 over 2. You get a common denominator. The tough things usually for students in this section are working with the fractions. Trying to figure this graphing stuff out, and then those fractions kind of keep tripping you up. So this 1/2 plus 2, or 4 halves, gives you 5 halves. And the pi is just, you kind of treat pi kind of like an x, right? So there's my endpoint. All right. Okay, so starting point plus the period is going to give you your end point. Then I start playing the halfway game. So I've got my 1 pi over 2, my start point from the phase shift, my end point from taking the phase shift here plus the period. Now, I did not have those. So all I had was this 1 pi over 2 and 5 pi over 2. So notice how I accented the 1 and the 5. This 0 right here is halfway. Well, what's halfway between 1 and 5? That's 3. Now, do you know how to find a halfway point? Well, you add them up and divide by 2. Halfway between 1 and 5 is 1 plus 5 is 6, divided by 2 is 3. So that's a 3 pi over 2. Notice how I'm just leaving the pi over 2's alone here because those are kind of constant throughout here. So now, by doing the halfway game, I've got 1, 3, and 5. Knowing that these are equally spaced points, you know that this 0, max, 0, min, 0. You can then figure out the halfway point here. You can already see the pattern, I hope, right? 1, 2, 5, or sorry, 1, 3, 5. So we got 1, 2, 3, 4, 5. So I accented that yellow stuff to show you that I start off playing the halfway game and then I look for a pattern. So this is kind of my technique every time. I use the phase shift to give me a starting point. I take the starting point plus the period to give me my ending point. I find the halfway point to get this other 0. And then I just try to find a pattern, because there's always a pattern in there. Finding that pattern is going to mean that we need common denominators. So just keep that in mind. All right, let's do a cosine graph. This cosine graph is going to have a phase shift. Because that's a minus, that's going to be to the right, just like the last example. So this is going to go to the right, pi over 3 units. Again, we have an a value of 1, a b value of 1. So my amplitude is still 1. My period is still going to be 2 pi. That's not going to change. All right, so there's some of the things to notice about the graph. All right, so having a phase shift to the right, pi over 3 units. Just like last time, I'm going to move to the right, pi over 3. There's my starting point. Now for sine, we know that for the sine function, we start on the axis and go up, down. For cosine, we start up here and we go down to the min, back up to the max. So that's what the cosine graph looks like. And then we've got all these kind of key points along the way. From here, this pi over 3 to this end point of 1 period is 2 pi. All right? So from here to there is 1 period. That means if I start at pi over 3 and I add 2 pi, that'll give me this endpoint. All right, in order to add 2, I'm going to have to rewrite that to have a denominator of 3. So that's going to be 6 over 3. You know, there's an understood 1 there. That gives me an endpoint of 7 pi over 3. Okay, now we're getting somewhere. All right. It's time for the halfway game. So that's a 1. Notice my 3's are the same here. What's halfway between 1 and 7? Remember how I told you the trick of finding halfway? You add them up and divide by 2. 1 plus 7 is 8, divided by 2 is 4. Okay? So this is 4 pi over 3. Okay? All right, so 1 to 4, eek. That's not good. Because 1 plus 4 is 5, divided by 2 is not a nice whole number. Yuck. All right, so what do we do? How are we going to find these other points here? Well, if this halfway game kind of, fails, you just need to up that denominator. Okay? So here's what I'm going to do. Let me grab another color here. I'm going to double this. Okay, I'm going to make that 2 pi over 6. I'm going to double the top and bottom here. That's going to be 8 pi over 6. I'm going to make that 14 pi over 6. Well, what in the heck did that just do? Well, what's halfway between 2 and 8? Well, 8 plus 2 is 10. 10 divided by 2 is 5. So that'll be 5 pi over 6. So you see what I'm doing here? Look, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So all I did was double the top and bottom here, because right here it got a little weird when I did halfway between 1 and 4 wasn't pretty. It was a fraction. It wasn't a nice, whole number there. So that is kind of what I did. So here's more pretty of what I did. And, I did the starting point, the ending point. To get this, halfway between 1 and 7 is 4. Now here, the halfway between pi and 3 and 4 pi over 3, you can see I went ahead and added it up and divided by 2. That's how you can find the halfway point, and got 5 pi over 6. If you didn't want to do all of that fraction work, that's why I did this as well. So this is where I just kind of doubled the top and bottom. That's essentially multiplying by 1, because I multiplied by 2 over 2. So I didn't change the fraction, I just rewrote it with a different denominator to maybe have that pattern show up a little better. And it worked, so. Okay, so just some tricks for you to try. Alright, so let's write the equation of the graph of sine x that has an amplitude of 4 and a period of 4 pi. So this one's different. I'm not giving you the equation. I'm asking you to work backwards from the information to get the equation. Okay, so an amplitude of 4. So where is that going to go in the equation? Well, we know that a goes right here before the sine function. The period is 4 pi. That's not your b value. Be careful. Your final period is 4 pi. That means when you do, when you do that 2 pi over b business and you get the new period, that means that that is 4 pi. So we have to find what number is going to go right here, because our equation is going to be y equals a sine bx. We know what a is. That's 4, it's the amplitude that we're given. B, we're going to have to find that by solving this equation, or if you wanted to do some guess and check to figure it out, you could. Alright, so got the 4 in there for the amplitude. The b was 2 pi over b is 4 pi over 1. Now, the way that we can solve this is by cross multiplying. Look at this as a proportion. So we get b times 4 pi equals 2 pi times 1. So 4 pi times b equals 2 pi times 1. And then solve this for b by dividing both sides by 4 pi. The pi's cancel and you get b is 1/2. So my final equation ends up being 4 sine 1/2 x. If you check this, okay, yes, amplitude is 4. And the new period? Well, the new period would be 2 pi over my b value, which we just found to be 1/2. 2 pi divided by 1/2. See what I did there? Instead of dividing by that fraction, I multiplied by its reciprocal. And I got that new period of 4 pi. Boom. So yeah, I thought that was pretty cool, that working backwards business here. Okay, so let's put some of this together, all right? We are going to have a period change and a phase shift with this one. But first, we're going to need to factor out that 2. Because of the standard form, okay, because of the standard form, it has b out here. And it has that coefficient of x inside the parentheses as being 1. So let's start off by factoring out 2. So if we do that, remember factoring out means division, or undistributing if you want to think of it that way. So by factoring out that 2, I'm left with x minus pi over 4. You may wonder, where the heck did pi over 4 come from? Well, think about redistributing it. 2x minus 2 pi over 4. 2 over 4 is the same as 1/2. So I essentially took this 1/2 and divided it by 2 and got 1/4. And pi's along for the ride. So here's what we got. We got a phase shift to the right, pi over 4 units, and we've got a period change. Okay. So that's the stuff that I just said, where we took the pi over 2, factored out 2, or divided out 2, and so that's how I get the pi over 4 out of it. So I have an amplitude of 1. My new period is 2 pi over that 2 right there, which is pi. And I have a phase shift to the right, pi over 4. Remember, in WebAssign, that would mean a positive pi over 4 phase shift. All right, so here's what my graph's going to look like. I shifted it to the right, so my starting point, it's a sine graph. That means I'm starting on the axis, as opposed to a cosine graph where I start at there at 1. I'm going to start right here on the axis, and I'm going to have this kind of shape for that sine graph. These points did not come about magically. There was some work involved. I had my starting point of pi over 4. That came from my phase shift because I went to the right. The ending point here came from taking my starting point and adding the period. So taking pi over 4, starting point, adding my period of pi, which is 1 or 4/4. 1/4 plus 4/4 is 5/4 pi. So here I've got 1 and I've got 5. So the middle is, we start the halfway game. What's halfway between 1 and 5? No, 1 plus 5 is 6. 6 divided by 2 is 3 pi over 4. Now, what's the pattern happening here? 1, 2, 3, 4. The pi over 4 business is the same throughout. All right, so this pattern thing can be used. It's just really cumbersome and tricky at first, but for me it's easier to do the pattern than it is to just keep doing all the computations of adding them up and dividing by 2. So if the computations are easier for you, then yeah, do it. Okay, when I ask you to graph these, I am going to want you to label the exact same things I'm labeling. The 3 zeros, the max, and the min for the graphs. So. Okie dokie. 2 more examples. I know this is kind of long. These take a little while. All right, this one's going to have a phase shift. Oop, you probably want to see it. Maybe you don't now that you've seen it. This one's going to have a phase shift, an amplitude change, and a period change. So you can see what we're doing here, right? We're just kind of building up to just like the worst case scenarios. Just like last time, we're going to factor out a 2. Remember, factoring out is dividing both of these by 2. So, dividing out this 2, so this 2x divided by 2 just gives me x. Pi, factoring out the 2, that's what factoring out the 2 means, gives me that pi over 2. All right, now we can see what's going to change. I'm going to have an amplitude of 1/2, so my graph is going to be stumpier. I'm going to have a period change, and I'm going to have a phase shift. This is a plus, so it's going to be to the left, pi over 2 units. In WebAssign, the left is going to be a negative pi over 2 phase shift. So when WebAssign asks you for the phase shift, you're going to have to say negative pi over 2. My new period is 2 pi divided by 2, trying to color code this stuff for you. Okay, so we have a shift to the left. That's unusual. So we have, I say unusual just because we haven't done one like that yet. It's actually not crazy unusual. So if we're going to the left, that's going to put me here at negative pi over 2 as my, kind of unofficial starting point. It's a cosine graph, so I'm going to start up here, and then, you know, it's going to kind of go down, up, and end somewhere over here. But where? You know, is it going to go through 0, 0? We don't really want to sketch it out just yet. So here's my starting point. Got a little aggressive with that thing there. So my starting point's negative pi over 2. My period is pi. So I'm going to need to add pi. I need a common denominator, so that's 1 pi right here in red. 1 is the same as 2 over 2. So this is a negative 1 because I had to move to the left. So negative 1/2 plus 2 over 2 is going to be a positive 1 pi over 2. Oh, that's interesting, isn't it? So this distance right here is pi over 2 to the left. This is pi over 2 to the right. That's my 1 period. It's very smushed because I didn't stretch it out very well. The halfway point here for this one, oh my gosh, very easy, right? Because it's just 0. So it's going to go, let's see, how am I going to do this? In my little tiny space provided. Oh, sorry, that's also, halfway point is not a 0 for cosine. So that, my amplitude here is 1/2. So I'm going to put a 1/2 and then try to make this one equidistant. Negative 1/2. So yeah, no, my halfway point is going to be down here. Sorry about that. All right, let's see if I can draw this. I'm a little upset at myself for not making this bigger. Okay. No, it keeps going that way, keeps going that way. And then we do have to play the halfway game with those. But luckily, that being 0, halfway between 0 and negative 1/2 is just negative 1/4. Halfway between 0 and 1/2 is just 1/4. Now, lucky for us, I did a better job on the original notes. I didn't want to just kind of show you and point to the answers. Luckily, I spaced it out a little bit better on here than I did on that first graph. All right, so we got that starting point, negative pi over 2 from that shift to the left. Added pi, because it's the period. There's my ending point. Halfway between those two is 0 pi over 2. If you can't see that, then remember halfway you add them up and divide by 2. So 1 plus negative 1 is 0, divided by 2 is 0. And then halfway between these two, you can add them up and divide by 2. I just used, halfway between 0 and negative 1/2 is negative 1/4. If that's not something that you're familiar with, if you look at that and you're like, gosh, I don't just know that. I just think, oh, well, it's basically half of a half is a 1/4. That's what got me to there. But if that's a little confusing, you can always go back to halfway between two numbers is adding them up and dividing by 2. So you can add up those two fractions, divide by 2. And you can ignore the pi. I mean, it's just along for the ride. Okay, last one. I know this is creeping up on a 30-minute video, which is a lot longer than we're used to. Thank you for staying with me this long. All right, let's just get this one done. Graphing this thing. We got amplitude change. We got a period change. We got a phase shift. We got all kinds of stuff happening here. This is already factored out, so you're welcome for that one. We get an amplitude of 5/4. Period. 2 pi over b right here. 2 pi divided by pi over 2. Remember, if you divide by a fraction, it's the same as multiplying by its reciprocal. We get a period of just 4. No pi, just 4. The phase shift, again, doesn't have a pi in it. It's just 2 units. Which way? See that plus? That's the left. So in web assign, you would say the phase shift is -2 because it's left 2 units. All right, so I'm going to start off 2 units to the left. All right. There it is, 2 units to the left. I'm going to have to add in my period. This is so much easier because we don't have fractions. So while this started off looking, you know, like a dumpster fire that you didn't want any part of, now all of a sudden I got rid of a lot of these fractions and this just got a lot sweeter. -2 from 2 units to the left. Now add 4, my period. What's -2 plus 4? +2. Halfway between -2 and 2, 0. What's halfway between 0 and -2? -1. Halfway between 0 and 2, 1. This is a sine graph. Remember the last one that looked kind of like this was a cosine graph, so I had to start up there and go, right? This is the amplitude's 5/4, so you can see I put my max there and my min down here at -5/4. But look at how much nicer these numbers are without those fractions, without those pi's in there. So I just wanted to show you one like this where the kind of the fractions and the pi's just kind of went away. It's really super cool when that happens. So, all right. So this finally concludes section 8.1 for us.